A project that is funded by the Fuel Cells and Hydrogen Joint Undertaking. And the other flagship project is the FitUp project, where we are mainly dealing with backup systems and with remote area system, off-grid system that will supply energy for different kind of application. So I have the pleasure to invite the first speaker, Madame Eva Ravn-Nielsen from the Danish Technology University, DTU, who will present the Danish experience in smart grid, and I think she will start with the Enefield project. Welcome.
Thanks a lot. Good afternoon, ladies and gentlemen. My name is Eva Ravn-Nielsen, and as you were just told, I will inform you about the Enefield project, which deals with micro CHP units and field demonstrations over Europe. And this is actually a kind of a double presentation, because second half of my presentation will explain you about the Danish efforts within smart grid. I have one pointer here. Yes. The Enefield project has received funding from the European Union's 7th Framework Program for Fuel Cells and Hydrogen Joint Technology Initiative. Now I have said it. So, I'm Center Manager of FCH Test Center at the DTU Energy Conversion within the Technical University of Denmark. I will very briefly inform you that we do testing, training, consultancy, and project work with industry within fuel cell and electrolysis. Now, also a brief introduction to micro-combined heat and power. This is a technology which is co-generation of heat and power in your home, supply electricity and heat to private homes, fueled usually by natural gas. It can also be hydrogen or biogas, and a typical size is 1 kilowatt power. Fuel cell micro CHP is highly efficient in the electricity production. So compared to other cogeneration technologies, the electricity part is higher than the heat part. And this makes this technology very useful for houses with a low heat demand. And as you probably all know, this is the direction that the European houses go due to new building codes, that the heat demands will become smaller and smaller. Micro CHP fuel cell based is a very good solution for this. Further, fuel cell micro CHP is important for the future smart grid. It may help balancing the grid by responding to the grid's need for additional electricity, And it may be installed with an additional heat storage, and therefore it can maintain very high efficiency, even though it has to respond to the grid needs and not only to the house's own energy demand. Now, regarding the Enfield project. This is a high-profile project for FCH joint undertaking. It is the largest demonstration project within stationary application. It is the largest demonstration of fuel cell micro CHP units for private homes. It will install up to 1,000 units in 12 different countries over Europe. The project runs for 5 years, from last year and until 2017. The project consortium consists of as many as 26 project partners, which includes 9 large manufacturers of micro CHP units. It includes utility partners, as well as research institutes and universities, as the one I represent. And the demonstrations include all the variants of fuel cell technology used in micro CHP, that is high as well as low temperature PEM fuel cells, and intermediate and high temperature solid oxide fuel cells. All these kind of technologies will be demonstrated in this project. Here is the impressive picture of all the partner logos, and a really important thing about this project is that it makes these manufacturers that may see themselves as competitors work together and make all this experience and make the real life towards a market. We have to do this together to be efficient in a number of learning points and barriers that has to be overcome. I myself is responsible for the work package regarding analysis. We do a number of analyses to extract as much information as possible and learning points from all the field trials that is going on in the project. A total cost of ownership analysis will tell and identify the most favorable house types and the most favorable regions for installing micro CHP. We will identify the training needs for technical personnel. There is already activities going on, and we will point forward what extra activities are required, and we will try to initiate the required actions together. We will have a look at the present regulations, codes and standards, and again, we will point forward what further is required in order to have this technology rolled out. We will make an analysis of which barriers there are to overcome in order to make a big mass uptake of this technology, and we will identify which of these barriers will have to be taken care of in policy, and what else can we do to overcome the barriers that indeed are there. By doing life cycle assessment, we will show the environmental impact that this technology has, and it really is a good environmental story because it is so efficient, using the gas much more efficient than competing technologies. And we will look at the business models, and for utilities, how can this technology come to life, and what roles should it play, who will be the ownership. We will have a look how we will have routes to market. And not least, the smart grid integration. We have an activity ongoing on this, and later in this presentation I will tell you quite some more about the smart grid. I will highlight a few opportunities. Being part of the ANALYSES project allows you to participate in the early market, to get the first experience, and to get the information as soon as it exists. All the large fuel cell manufacturers of Europe are investing in this project to develop the market and to improve the product offering. So this is the place to be if you want to have the learning. And participants in the ANALYSES project gain valuable market and product knowledge ahead of time, and also gain the communication benefits of working with a flagship European project. The reason why I'm highlighting all these opportunities is that we are keen to talk to utilities who wish to get involved with the ANALYSES project. The manufacturers need more utility partners to go out and make the demonstration in practice. Often it is the utilities that have the direct contact with the end users and the house owners. We have a utility working group where they get the first informations and they exchange experience. This will be a very important forum for utilities that want better insight to this market. And for more information on the ANALYSES project, you can either visit the project website or contact by email. And also, Maria from Cogen Europe will be at the FCH joint undertaking booth rest of the afternoon. And of course, you're also welcome to contact me, or many of the manufacturers are exhibiting here at the group exhibition. Now, very short break before I continue with the smart grid. In Denmark, we are doing quite some activities on the smart grid because we have to do it. The Danish government has the vision that the country should be independent on coal, oil, and gas by the year 2050. And one of the visions is that we have to have an interplay between power and gas in order to get rid of be independent of the fossil fuels. This figure shows you that we have some primary energy forms, biomass and renewable energies. They have to be converted in a form that we can use in our energy systems, either as electricity or as gas. We need further connections internationally, international infrastructure to make us less vulnerable of the fluctuations. When there is a surplus of electricity, we use electrolysis to produce gas. Gas can be stored, it can be fed into the gas systems, gas grid, or it can be refueled to fuel cells or to automotive industry and give power back to household or to the grid. To be independent of the fossil fuel, the wind power makes up larger and larger part of the Danish energy system. In 2009, wind made out 19% of the electricity generated. Already today we are at 30%, and in 2020 it will make up 42% of the electricity production. This gives us some challenges, because sometimes the wind power is smaller than the overall energy demand. But in the future, and already today sometimes in the future, more and more often, the wind power covers all the energy demand and somewhat more. So we have to store this energy. Also, we have fluctuations on short time scale. This is just to show you that this from hour to hour, and within 15 or 20 minutes, there can be a very steep variation between what wind power is actually generated. Therefore, the grid needs balancing. Therefore, the future grid must be smart. I will give you very concrete examples on some of the activities we are doing in Denmark to be prepared and to learn more. In Denmark, we have a Danish micro-CHP project, very similar to what we do in the energy field, but much smaller scale. And like the German Kalux project, more countries have experience with micro-CHP already. These are the Danish partners. But what I want to show is what work they actually did already trying out smart grid capabilities. So it was decided to take 4 houses equipped with micro-CHP based on fuel cells. And a communication protocol was made. Dong Energy has what they call the power hub that communicates and controls the energy demand. This was sending signals to fuel cell systems based on low temperature PEM produced by Danterm Power. And the remote control software is already installed in the fuel cell control system. There has been testing of 4 systems, 4 different houses in Denmark. They did not react on actual price signals. They were not depending on the electricity prices in Denmark. This was simulated by a schedule decided on front, but we were testing out if we send the signal, now the electricity price is high, you need to produce more to put electricity back to the grid, then the fuel cell unit should react. And actually, the 4 houses got 4 different profiles that of the signal structure. Please produce, please do not send power to the grid. And in total, it reflects an energy demand of the grid, like the one you see here at the bottom. That's the sum. And the results were that 100% of the start-stop signals from the power hub was received correctly by the fuel cell units. So the communication technology works in this field. Only one of the systems had a startup problem, and it turned out that only 1 hour prior to this start, there had been a service. So it was not up running full, but it was starting up and was not ready to send power back to the grid. And the power hub correctly quarantined this system for 4 hours, whereafter the signals was transferred again, and this time starting up correctly. It works. In general, hydrogen and fuel cell technologies offer an important balancing of the grid, important role in the future smart grid. We have a number of various technologies that can help you out on different time scales, from seconds, minutes, hours, which is important for the smart grid, to up to months, which is a storage issue. And you can see from this sketch that the micro-CHP technology covers a lot of this time scale and all what is required to play a role in the smart grid. Another project with importance from the smart grid activities in Denmark is the European project EcoGrid. This reflects the Danish island of Bornholm. It is based here out close to Sweden. And in this project, it's actually possible to have this island operating in island mode, so there is no connection to the main land. In this way, Bornholm is the European smart grid laboratory with real people, real grid, and resulting in real solutions. The last project I will mention for you is Smart Copenhagen project. I must say We have not started up yet. It's still under negotiation with the Danish Energy Agency, which is funding it. It will be large-scale demonstration, megawatt scale of electrolysis, hydrogen storage, fuel cells, and other hydrogen consumptions like cars and town gas. And this is going to start up just now and take place over the next years. So, to summarize, micro-CHP is an important technology for the smart grid. And the large and important Enfield project offers opportunities, and we really want to go into more discussions with utility partners that would like to know more about this project and want to take part and be involved. So please contact us or partners. And I showed you that there are a lot of efforts in Denmark getting more knowledge on the smart grid, and I think this will not be the last thing you hear about the Danish smart grid efforts. I have to thank my Danish colleagues, especially from Energinet DK, Dansam Power and Dong Energy, who let me use their slides for this presentation. And finally, thank you for your attention. You're welcome to contact me. We have a booth here at the fair, or contact the Enfield project directly with the coordinator, Cogen Europe. Thank you very much.
So thank you, Eva. It's time now for questions. Are there any questions to ask first from the Enfield project? Who wants to raise the first question?
Good evening. I am from India. I just wanted to know for this micro CHP, what will be the temperature effect? Because normally India has got 40-degree temperature. So any performance will be deteriorated for micro CHP?
Sorry, I don't get the question.
In India, I am from India. I am from India, and in India there is a high temperature, normal ambient temperature. So what effect it will have? Can you give some idea on that?
Yeah, if you have houses without any heat demand, then some of the efficiency you can't count in. And that also goes for European houses. In Denmark, we have a lot of district heating, so the heating is provided from other sources. And there, micro-CHP is not the perfect solution. But if you want to be independent and produce your own electricity, it's still a very efficient method, and make the house owners what we call prosumers. They produce electricity and then consume electricity.
Also produce some cold with heat. So that's also a possibility on your side. Another question? On the Enfield project, maybe I have one. How do you select the people who will have the houses with the micro CHP?
We are, in many ways, finding end users and utilities that will help us out in the end. There are some information on the webpage on how householders can contact if interested, but mainly it is the utilities that go out in their local area, and we want to usually not make projects less than 10 houses in some region, and then it's the manufacturer and the utilities that go together, and of course there are a few demands to the house size, and the energy demands.
So it's also a question of maintenance. You want to have a local community in order to decrease the price of maintenance of the system.
Yeah, they don't need to be very close. They don't have to be at the same street, but it's not like we want to make one project in Ireland and then two in Sweden.
Okay. Other question? Yep.
Are there any plans how to exploit the findings of this program, this project already, or will you leave the companies alone after this project has been finished?
Well, I guess there are no decisions on any continuation. We will, of course, communicate the results, and there is a strict plan already, which reports is internal, which are external, and in the end, there will be a lot of public information, because what we also want is to spread the information and the knowledge, the experience we get with all these field trials, and we want to talk to politicians and organizations that can help making this become true.
Yeah, just a general remark for this. As it is a FCAGU funded project, it's funded with public money. So of course, the results, general results of the project will be available. That's not a problem.
The question was more like, what is the technical outcome? So how will these technical results be exploited in the industry, into products? How will it enter into the market, you know?
Yeah, this is a key application for all the manufacturers involved. And all the units will run not less than 3 years, each unit. And they gain experience and they take it in as part of their business strategy.
No, there are no concrete plans at this time.
I guess in this case, I would say every manufacturer for itself, and where it makes sense, people will of course continue to cooperate with like codes and standards, training issues.
What is important in this case is that you have the different types of technologies, as you have seen in the presentation, the PEM technologies, the solid oxide fuel cells technologies, and they are operating all together, and so they can also compare one with the other. And then you have some cross-fertilization between the different technologies and the different producers. And all the producers are working together in order to bring that to the market. But of course, for their own technologies, each producer is protecting his rights. That's quite normal.
But I will also say that having this variety of technologies also will show us that there is not what you could say one winner. There are different segments, different markets. They are not all the same size. I started out saying around 1 kilowatt, but we have smaller and we have quite some larger. They will go for different house types. They will go for different regions where they will be optimized.
You always have a balance between the heat production and the electricity production, and it's completely different from one technology to the other one. So you clearly need to identify where you want to input and deploy this technology in Europe. Other question?
Yes.
Yep.
Is indeed 1 kilowatt not too small for the household energizing? This tea heater requires sometimes 1 kilowatt, 1 kilowatt and a half.
If it's usual well-insulated house, 1 kilowatt electricity and then more than 1 kilowatt heat, up to 2 kilowatt heat, is what I would say is a typical size of energy demand. And we have larger and we have smaller. They are, but what is chosen here is of course because that's what the manufacturers see as the actual needs in the market.
This corresponds also mainly to what is developed in Japan. They are also in the same range of power.
The 1 kilowatt is the electricity.
Yeah, only. Other question? So let us thank again Eva for this nice presentation. And we will move then to the second presentation of this afternoon. The presentation in the program was Ilaria Rosso, but she is replaced by Emiliano Novo, who will present the FITUP project. The FITUP project is also a flagship project funded by the Fuel Cells and Hydrogen Joint Undertaking, and he will discuss more about the backup system and the off-grid system. You have the floor.
Yeah, thank you, Jean-Luc, for the presentation. Good afternoon, ladies and gentlemen. As you can see, I'm here to talking about the FITA project. I'm the scientific coordinator. But not only the FITA project, because we are in the third year of the FITA project. It is a project started 2 years ago. So we are almost at the end of the project. We have all the systems installed, all the systems are running. So we have already some data that we have analyzed, and I'll show you in the presentation. I want to focalize the presentation in two basic points. The first one is the on-grid fuel cell backup solution. The second is the off-grid fuel cell backup, but only if you have energy storage system, because it's not useful to have a fuel cell if you don't have the fuel and if you have to refill the unit with fuel logistic. So, just a recap of the competitive advantages comparing the traditional solutions. Traditional solutions are basically batteries, lead-acid batteries, or new kind of batteries like lithium batteries or natrium sulfur batteries, and diesel genset. Because if you need just a backup for 5 minutes to switch off your PC, you need only batteries. But if you need many hours of autonomy, you cannot do that only with batteries. You have to add a diesel genset. Diesel genset, usually, it is a system that helps the batteries when the blackout is more than half an hour, 1 hour. But you need to put the diesel inside. You need to have a lot of space for the installation. And also the weight is very important, not talking about the noisy of the diesel genset. You cannot put the diesel genset in the urban areas. The result of this analysis of the big advantages that fuel cell technologies has in this field, in the backup solution, is that you have a very reduction of the operational cost, and you have a positive total cost of ownership with a return on investment basically in 2-3 years. The byproduct of the fuel cell is only pure water and the heat. The only disadvantages that I put here is the logistic, the fuel logistic, but not anymore. There is a solution, and I will show you in the next slide how. To show you that we have already done a lot of things in this field, not only in the FITAT project. As an electropower system, we have more or less 650 units installed worldwide in 5 continents. We are present in Europe, we are present in the North America, we are in Africa, we are in China, we are in India, we are in Southeast Asia, and we are also in Australia. Basically, there is a lot of differences about the national grid. If you are in Europe, this is very stable. If you are in North America, where there are private companies that doesn't want to exchange electricity locally. But if you are in rural areas, in Australia, in India, in China, or even if in South Africa, you need to have a lot of kilowatt hours stored for your solution. You can have that with traditional solution, or you can have with this innovative solution using the hydrogen. Let me back in this slide. This is a test in action where, after decommissioning, we had 2 long outages, one of 5 hours and the other one of 3 hours. This is out of the FITAT project. This is a real exercise that happened in India. Just to summarize, to focus on the particular application, when the grid is off, you can see that the fuel cell power system has to start suddenly and power the load. Typically, this is a telecom operator. Typically, telecom operator had a load from 1.5 up to 3 kilowatt in a tower. If we are working in a sharing or it is a very important tower, it could be also to increase at 6 or up to 10 kilowatt output. So as you can see, in this case, we have a basic load of 2.5 kilowatt. When the fuel cell is running, the green line, it is the hydrogen pressure in the cylinder, decreases. When decreases back, the hydrogen generator, the all-in-one solution, fuel cell and hydrogen generation, stops the fuel cell and starts to recharge the cylinders using the hydrogen generator. But if I have another grid fault, I need to stop the hydrogen production and restart the fuel cell, other 3 hours. At the end of the day, when the grid is restored, I have the time to recover all the hydrogen in my cylinders. This is a solution that we call high pressure solution because there is a booster that increases the pressure up to 150 bars. We have also another solution that we call low pressure solution, but for us the low pressure solution is 30 bars, 30 bars in the cylinders, or in a storage tank that you can buy, you can source locally. After the experience of the poor grid, especially in Asia, we moved to thinking to use the ElectroSelf solution, that is the commercial product that the electropower system sell, to couple the fuel cell and the electrolyzer with renewable sources, solar array or windmill. Okay, fuel cell power system, it is a UPS solution only if you have a bridging unit that you have to put here. You can put small batteries, you can put traditional batteries, or you can put nowadays batteries like lithium batteries, you can put super capsules as you want. But the point is that the kilowatt hours are stored in a chemical way inside the hydrogen tank. The key advantages of this solution is the reduction of the footprint compared to the traditional solution, because you don't have to think about a big batteries, or you have to think about a big liquid tank for the diesel. Easy installation, because you have just to connect the positive and the negative cable to the DC bus. You have not to think about a lot of electrical conversion, AC to DC, DC to AC. Low maintenance needed. There is no rotation party inside the ElectroSelf product. It is a stationary application. So there is a fuel cell that is a static device. There is a electrolyzer that is a static device. 100% clean. Starting from electricity from the sun or from the wind and pure water, we can obtain again electricity when we need, because when we have renewables plenty, we can produce the hydrogen. When we don't have the renewable sources, we reuse the hydrogen to obtain electricity without pollution. The reliability of the system, it is a product based on the backup solution for telcos. Telcos asked to have 99.99% of reliability. So this is exactly what we need for the off-grid site where no one wants to go in nowhere. The flexibility and the modularity of the system is that you can have a solution from 1.5 up to 10 kilowatt on site in the same footprint, and you can have a modularity to put, okay, my load is changed because I started with just one single cell with 1 kilowatt load, but I need to increase because I have more customer in that area. I have to put other transmission devices. So I need to increase my power at site. I don't have to change all in the site. I have just to add another component. It is the reduction on the business continuity cost because there is no battery replacement and there is no disposal at the end. There is no issues related to the fuel replacement and logistic because you generate your fuel on site. With another innovative solution that we have in the ElectroSelf platform, we recirculate the water. So we're starting with the mineralized water. We generate hydrogen. From the fuel cell, we have as a waste water. Why not recover inside the starting tank? This is our internal solution. It is, and I link with the presentation before, the hydrogen is the perfect link with the irregularities that are coming from the renewable sources. So if there is a cloud that covers the sun, there is no electricity from the solar array, we need to start the fuel cell. And we can cover the gap of the electricity using the fuel cell. At the end, when the cloud is over, we can stop the fuel cell and generate a new hydrogen. This is the basic concept of our 2013 solution, where we have the electrolyzer here, and on the top, the fuel cell power system. You can see that for the connection, it is just the negative and the positive pole. Okay, the negative for the telecommunication is protected by a fuse. On the positive, there is a knife. The other important point of the electropower systems technology is that coming from the water and the electricity, we split the water molecule in hydrogen and oxygen. Obviously, for the fuel cell, we need the hydrogen, and also we need the oxygen. Usually, oxygen is taken from the air, but why we have to disperse the oxygen and pay in terms of electricity with a blower to blow the oxygen inside the fuel cell? Our decision is to, in some application, because we have two platforms. One is the AirTech platform, and one is DOX platform. So, in some application, the DOX platform, using the hydrogen stored gas and the oxygen stored gas produced by the electrolyzer, when we don't have electricity, we reuse hydrogen and oxygen. In this way, we are increasing the total efficiency of the system, because with 1 cubic meter of hydrogen with the AirTech solution, so oxygen coming from the air, we can obtain more or less 1.2 kilowatt hours. With this solution, we increase up to 1.5 kilowatt hour. It means that I can reduce again the footprint of the storage, or with the same footprint, I can increase the autonomy of the site. This is very powerful for the on-grid installation, and this is essential for the off-grid installation, coupling with renewables, where we need at least to have 3 or 4 days of backup, because it could be that there is a tropical storm and we have no light for 3-4 days. Or in other case, I have to do the maintenance to the windmill, so I have to stop. In that case, I have to power my load, because this is usually the base station with a longer backup autonomy are located in the backbone of the network. So if I have to reach the point C, starting from the point A, I need that the point B is always on. Just to be sure that it is always on, I need a very reliable backup solution with a long autonomy solution. Talking about the water. With the water recirculation that you can see here, in the DOX solution, I can recover 90% of the water every time. So if I start with, like an example, numeric example, with 100 liters of demi-water, I recirculate 90 liters of water the first time. The second time, it is 81. And go ahead, at the end, I have an equivalent of 1,000 liters in my water tank. So I have not to go on site when I use it 100 liters, but when I use it 1,000 liters, 10 times. So comparing to the traditional solution with the diesel genset, usually I have 200 liters of diesel on site, but at the end, when I consume 200 liters, I have to go and refill. In this case, it is automatically refilled by the fuel cell. So, basic of some calculation, I have to go to the site once a year and not 3 times every month. This is a basic OpEx advantages of this solution relating to the fuel. Just during the installation, I have to move the cylinders or the storage tank. After that, it is a part of my installation. In case I want to increase the autonomy, I can add more cylinders. Or in case I want to reduce, I can remove some cylinders. It is not like a batteries that when I decided the kilowatt hours, this is the kilowatt hours that I have at the day one. If I want to increase, I have to put other battery pack. But to increase other battery pack, it means a lot of volume and weight that I have to move on the site. In this case, this is just to add standard cylinders of 50 liters at 200 bars. It is more or less 10 kilowatt hours more energy that you have stored in the solution. The other point is that coupling this solution with big tank at low pressure and 30 bars, you can save again other electricity because you don't need to boost the hydrogen and the oxygen in the cylinders. If you have not to pay in terms of electricity, you increase the total efficiency of the systems up to 30%, electrical to electrical talking about. If you have the solution with the AirTech high pressure, the efficiency is more or less 25%. So 5 points more of efficiency, just not to waste the water, just not to waste the oxygen on site. This is a real opportunity talking about the economics of the telecom operators. And this is also a real opportunity for the rural areas where the access to the grid it's very hard because you have to pay, you have to wait a lot of time for the authorization. Also for the telecom operator to have this solution is very powerful because nowadays there are more or less 670,000 off-grid sites worldwide based on the GSMA numbers, but this number is increasing because the network especially in India and China, is moving on. But it is very easy to put the antenna. It is not easy to get the authorization to move the national grid from the centralized power plant to the remote areas, because I have just to put a cable, for this load. And if I'm a private company with my centralized electrical power plant, I don't want to pay for another one. And also the telecom operators doesn't want to pay a lot of money for the rural areas because they cannot reach a lot of people. But thinking about what's happened for the rural areas in Africa. So in Africa, just to open a bracket, the penetration of the mobile services is growing very fast. The point is that at the end, there is the antenna, there is the diesel genset running 24 hours or 7 days, but people who has a smartphone in the end has not a chance to recharge the batteries inside the mobile phone. So another application of this solution is to have 48 to 230 volts, 50 hertz, or 110, 60 hertz in the North America, to sell the kilowatt hour to the customer that can use the phones where they need to use the phone. This is the history. This is the first unit that we installed in Italy. It is 1 hour by car from Turin. This is our pilot system that we realized on the Piedmontese hills. We realized for a Wi-Fi antenna. So even if in Italy it is possible that there are some hills where in the top it is perfect to put a Wi-Fi antenna to cover a large area with a WiMAX radio apparatus. But you have to spend a lot of money to connect this antenna to the national grid, because It is more or less 5 kilometers, and it costs 20,000 euros per kilometer. At the end, you can have a solution with solar array, micro wind, because Italy, the north of Italy, is not good with the wind, but we want to show in the pilot that it's possible to couple both technologies, renewable technologies, to our solution. And we put not the first prototype, but not the first prototype for the ElectroSelf platform, but this is the first prototype for the ElectroSelf coupling with renewables. Because coupling with renewables, it means that we have to follow the sun, we have to follow the wind, and adapt the hydrogen production based on the kilowatt hour that we have coming from the renewable sources. So this is the grandfather of the off-grid solution that we present. We have already some trials, especially in India and in China, with this product. We approached the Australian market in the beginning of this year. But this is a grandfather, but this is a son of the first ElectroSelf that we developed in 2009 for the rural areas in India and in China. So we are now at the third product that we are presented in these days of the ElectroSelf platform. So we have 4 years of history with this platform, and we have 8 years history in the fuel cell backup solution. As I told before, we have already 650 systems installed worldwide. More or less 60% are backup power systems with cylinder logistic, and the other 40% it is with the ElectroSelf platform. So if it is cheapest to move the cylinders to the site, okay, only fuel cell power system. If we have some troubles to move the cylinders to the site, this is the solution that you can have. This is a product with CE certification, CSA certification, and not all the range, but for a couple of systems also the Chinese certification. Just a chart of the renewables. This is 1 week of data run, where you can see the solar, you can see the small wind contribution, and you can see the fuel cell contribution. So only when we have overproduction, so what we don't need to the load, we start the electrolyzer following this profile to generate the hydrogen that we need during the nighttime here. It is the basic calculation that we have to do before to install a unit, because we just to be sure that if we have 1 week with no sun and no wind, we can cover the electrical consumption of the WiMAX antenna. This is a chart related to the power and the pressure. This is more or less the same that I showed before for the Indian case, where we have the fuel cell power production or standby, and where we have the hydrogen production or hydrogen consuming. To move to the conclusion of my presentation is that for the on-grid fuel cell backup, this is a reliable and cost-effective solution if you are thinking not only the CapEx, but you are thinking about the TCO cost. In the near future, we expected using the on-field test in the FITA project, thanks to the FCHJU sponsorization, to decrease the cost and to compare CapEx by CapEx this solution. But this is the only solution for the off-grid site to couple the backup with energy storage, because this is the only way that we have right now to use or to accumulate energy without spending a lot of money. This is not a conclusion that I wrote for this presentation. This is what we offered starting from 2009 worldwide, and this is acceptable for all the customers that we have. The point that we still need to fight, let me use the fight in this case, is that, okay, this is a very good product, but we need to see some on-field installation before to move the first step. So thank you to the FGH-JU for the opportunity on the FITA project to show the real situation, that there is a solution that it works better compared to traditional solution, and it is also green.
Thank you very much. So thank you very much for this interesting presentation. The floor is open for questions. Any question?
My question refers to your suggestion to store the oxygen as well as hydrogen in your system. Do you see some extended safety issues with this procedure?
Yeah, this is a great question related to the safety, especially because there is not a standardization in Europe. There is in US, but there is not in Europe regarding the meters that I have to respect from the hydrogen to the oxygen. And talking about the Italian, we need to respect 5 meters distance from the hydrogen to the oxygen tank, or 5 meters. Or we have to put a wall to separate the hydrogen storage to the oxygen storage. This is an extra cost, yes. Talking about the CAPEX. Talking about the OPEX, I can generate 1.5 kilowatt hour instead of 1.2. This is the good point, yeah. In the future, the forecast is that also the storage related to high pressure or low pressure is not standardized. So we need, and we are working the FITA project, we have a working page, it is the number 6, relating to the certification, because there is the product certification, but there is not right now the installation standard for a fuel cell application.
Thank you. Another question?
Hello. You said that you have more than 600 systems running worldwide now. And so I would like to know, if it's possible, of course, which is, in terms of CAPEX, the actual cost of your systems in terms of, let's say, 10 units or 100 units, if available, of course.
Yeah. Talking about the prices with the fuel cell, it's always hard because there is no volume. But just to give an indicative price for 10, 50 units sold and power output of 3 kilowatt, that is the standard power that telecom operator uses at the site, it is more or less 25,000 euros. Complete fuel cell power systems with electrolyzer.
And the storage.
And the storage, yes. But usually the storage is a small part.
Another question? So on your point of view, what is the need in terms of regulation code and standards? Do you think that you can draw some good conclusions from your FITA project in order to implement a new norm and new regulation?
Yeah. Especially coming from the TÜV, we developed a checklist in Switzerland for the basic distances of this small hydrogen storage. Because usually when you talk about the hydrogen storage, you think about 1 ton of hydrogen, but this is just 5 kilograms of hydrogen on the installation site. So we developed a checklist after the installation, and basically it follows the EEC norms related to the ATEX directive that we have in Europe.
Okay. Other question? If there is no other question, then I would like to thank you again, Emilio.
Thank you to all.
And I would like just to close this session, just to inform you that if you are interested to see the results or to see what kind of portfolio of projects the fuel cells and hydrogen joint undertaking is funding, we have a document that is the review day document where all the projects are described shortly, with also the contact person and the name. We have a booth on location C56 where you can have this document very easily. Thank you very much for your attention and for the nice audience of this afternoon. Thank you.
Thank you very much for being here and for this nice and interesting European Day here. It's ending now, this part of this technical forum. We have a short break, and after 10 minutes we continue with the next the next point of the program with the company presentation by Cell Energy. Thank you very much.